Hello students, welcome back to my channel. In this video I am going to share chemistry Eamcet 2025 multiple choice questions based on chemical bonding. Which one of the following molecule is expected to exhibit diamagnetic behavior? Option A C2, B N2, C O2, D S2. Pause the video and try to answer the question. To explain the magnetic behavior of the molecules, we have to draw molecular orbital diagrams. So coming to the molecular orbital diagram of C2, its atomic number is 6 and its configuration is 1s2, 2s2, 2p2. So let us concentrate on p orbital. So p orbital of carbon atom contains 2 electrons. So each carbon atom contains 2 electrons in the p orbital. 2p2. So coming to the filling of the molecular orbital, on the whole 4 electrons are present. So coming to the molecular orbital 1, 2, 3, 4. So C2 molecule contains only paired electrons. So due to the absence of unpaired electrons, C2 is diamagnetic in nature. Moving to N2 molecule, here the atomic number of nitrogen is 7 and its configuration is 1s2, 2s2, 2p3. So p orbital contains 3 electrons. So coming to the molecular orbital of nitrogen, here 2p3. Altogether 6 electrons are present. Already 4 electrons are filled, 5, 6. Again N2 contains only paired electrons. So due to the absence of unpaired electrons, again N2 is diamagnetic in nature. Moving to the oxygen, here sulfur also belongs to the oxygen family. So once we consider the molecular orbital diagram of oxygen, it explains the behavior of both oxygen and sulfur. So the atomic number of oxygen is 8 and hence its configuration is 1s2, 2s2, 2p4. 1, 2, 3, 4. 1, 2, 3, 4. So altogether 8 electrons are present. 1, 2, 3, 4, 5, 6, 7 and 8. These are called as degenerate orbitals. They must be filled with single electron each, then only the pairing starts. So undoubtedly, due to the presence of unpaired electrons, oxygen is paramagnetic and also sulfur is paramagnetic in nature. And hence carbon and nitrogen are diamagnetic in nature. So both option A and B are right answers. Coming to the second question, which of the following compounds contain no covalent bond? So in general, a covalent bond is formed between two nonmetals, whereas an ionic bond is formed between a metal and a non-metal. So let us see the options. Option A, potassium chloride, sulfuric acid. B, potassium chloride. C, potassium chloride and diborane. D, potassium chloride, diborane and pH3. So pause the video and try to answer the question. Among the all compounds, only potassium chloride contains ionic bond and hence the right option is option B. Moving to the third question, according to molecular orbital theory, which of the following will not be a viable molecule? Viable molecule means stable molecule. Not a viable molecule means that molecule will not exist. Coming to the options, A, He2 plus B, H2 minus C, H2 minus 2 and D He2 plus 2. Pause the video and try to answer the question. So let us draw the molecular orbital diagrams of helium and hydrogen atoms. So atomic number of helium is 2 and its configuration is 1s2. Coming to helium plus 2. Here 2 electrons are drawn from the helium. So they contain only 1 electron each. So when they are filled in the molecular orbital, it will have bond order 1. But coming to the helium He2 plus, here only 1 electron is removed. That means one helium will have 2 electrons and the other helium will have only 1 electron. And hence here 1 electron will be present in the anti-bonding molecular orbital and its bond order will be 0.5. Moving to the hydrogen, here H2 minus. What is the atomic number of hydrogen? 1. So it contains only 1 electron. Coming to H2 minus, 1 excess electron is present. Actually hydrogen contains only 1 electron. So 1 excess electron is present. So coming to the filling of molecular orbitals, here the bond order will become 0.5. Moving to H2 minus 2, each hydrogen contains 1 electron in excess. So here the bond order is 0. How to calculate bond order? Bond order equal to half into the number of electrons in bonding molecular orbitals minus the number of electrons in anti-bonding molecular orbitals. Here 1 by 2 into 2 minus 2. Here the bond order is 0. So H2 minus 2 molecule will not exist. So option C is the right answer. Coming to the fourth question, total number of lone pair of electrons in I3 minus ion is option A 6, B 9, C 12 and D 3. So iodine means it is halide. So halogen contains 7 electrons in the outermost orbit. So it contains 3 lone pair of electrons, 1 unpaired electron. So let us draw the structure of I3 minus. 3 iodides are present. Yes, here each iodine contains 3 lone pairs, 1 unpaired electron. Yes, during the bond formation, 1 unpaired electron will be consumed. And here it is I3 minus. So 1 excess electron is present here. So altogether each iodine contains 3 lone pairs and 3 iodines are present. Altogether 9 lone pair of electrons are present. Hence the right option is B. Coming to the fifth question, which of the following type of bonds is responsible for the high melting point of ionic compounds? A. Covalent bond, B. Ionic bond, C. Hydrogen bond and D. Van der Waals bond. Pause the video and try to answer the question. Especially ionic bond is responsible for the high melting point due to closed packed structure. Hence option B is the right answer. Finally, I would like to conclude this video by sharing the test question. What is the shape of the molecule having sp3 hybridization? Option A linear, B trigonal planar structure, C tetrahedral, D square planar. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.